Our next lesson will be on symmetry. For the first part, we do discuss the different types of symmetry that we may have. And for this first one, if we are able to take the graph and fold it along a line so that the two halves match, then that's going to be what we call a line symmetry. Okay, for the next one, the graph remains unchanged when rotated 180 degrees. Remember, 180 degrees would be that direction, or we could even do a negative 180 there. And so that would be a point symmetry. There's the different types of symmetry. Now, underneath here, we are told that the x-axis and y-axis are common lines of symmetry. The origin is a common point of symmetry. And so the following graphical and algebraic tests can be used to determine if the graph of a relation is symmetric to the x-axis, y-axis, or the origin. So notice we have two different tests here, and we will be incorporating both of those. So be very careful with these. So on the graphical test, for every point xy on the graph, the point x, negative y is also on the graph. So the algebraic test that is going to work with this is we're going to replace our y value with negative y. And if we end up with equal equations, if we end up what we began with, then we will be an x-axis symmetry. So for the next part, for our y-axis symmetry, for every point xy on the graph, the point negative x, y is also on the graph. And again, that's going to give us symmetry about the y-axis. And the algebraic test for this would be replacing x with negative x, and you get the same equation you started with. And then finally, for the origin, for every point xy on the graph, the point negative x, negative y is also on the graph. So that means we're replacing y with negative y, and so this test we're going to have to do both x and negative x. And that's going to result in equivalent equations. So we have to look and see, are we getting back the original equation we started with? Alright, so let's look at some examples, and do keep these different tests in mind as we're going through these. So for number 1, we need to see, well, where are we symmetric about? And so we can go through our different tests. If we wanted to check for the x-axis, remember the algebra approach would be to replace, and I'm just going to write this in so we have it in front of us. We're going to replace y with negative y. And we're going to see if we have the same exact equation that we started with. So if we replace y with negative y, notice that's going to give me negative y equals x to the 4th minus 4x squared. That is not going to generate the same exact equation because I would need to flip our signs to get that to be y equals. And notice that was not the same, so I know it's not symmetric with the x-axis. So now let's do the y-axis test. And the y-axis, then that's where we replaced our x with negative x. So we have y. So again, let's write in, we are going to replace x with negative x. So we still have our same y equals, and then we're going to have negative x raised to the 4th minus 4 times negative x squared. So here, once we work that out, notice we do maintain the original function. So notice this is exactly what we started with way back up here. So we are going to be symmetric about the y-axis. Okay, number 2, again, same process here. We need to go through our different tests. And so here, again, if we make x about the x-axis, we're checking that symmetry. About the x-axis, then here we are going to plug in or replace y with negative y. Well, if I replace y with negative y, that's going to be x stays the same, y becomes negative. That is not going to be the same equation that I started with. So the x-axis is out. Then we would look at the y-axis, and for the y-axis, we replace x with negative x. And again, it is not going to give us the original. So for the origin, we replace both. So symmetric about the origin, then we need to plug in both negative x and negative y to see if we end up back with the original equation. And for this one, we will. So the origin is going to be what we're symmetric about for number 2. Alright, so for number 3, carrying on the same idea here, we do need to do some replacing. And so here for the x-axis, again, we need to replace the y. So we are going to have 4 times x plus 3 all squared plus, and then replacing this y with negative y all squared equals 16. And notice when I square that negative y, it should maintain the same exact equation that I started with. And notice it does. So that means we are symmetric about the x-axis. Okay, with number 4, let's go ahead and check this one. And this is a strange looking graph. So let's go ahead and start with the x-axis. So with the x-axis, that's where we replace the y with negative y. And so let's see, it looks like we're going to get back the same exact equation that we started with. So we are symmetric about the x-axis, but this shape is awful peculiar. We might want to go ahead and check the others. So let's check our y-axis. And if we check that y-axis, then we are going to change x to be negative x all squared. And notice what happens with this one. We're going to have y squared minus x squared again. So we, once again, maintained that original equation. Well, what about for the origin? This one's really a different type of graph here. So for the origin, this is where we replace both. So we have negative y squared minus negative x squared. Is that equal to 1? Well, it's going to generate the same exact equation again. So that's pretty cool. That one is going to also be symmetric about the origin. Now, this is one of those strange cases where it just happened to work out like that. And it doesn't always have to. So notice here we saw real quick that this one, being as strange as it is, it does work for all of them. Alright, so for number 5, and again, starting out our steps for the x-axis. So x-axis, have to show that test. So that's going to be replacing y with negative y. I have negative y equals the cube root of x minus 1. Well, if I move this negative over, I'm going to have y equals negative cube root of x minus 1, which is not what we started out with. It's really the opposite. So x-axis is out. And if the x-axis is out, probably the origin is going to be out as well. But we need to be careful because we could end up with two negatives canceling each other. So what about the y-axis? Well, the y-axis says that I need to replace x with negative x minus 1, and that's definitely not the same, and there's nothing we can do with that, so that one's out. Well, now let's try the origin. And for the origin, we need to replace both y and x. And again, we can move that negative over, but there's not much we can do past that. So the origin is out, so that means this one is none. None of it, we are not symmetric about any axis. All right, and then number 6, again, starting out, let's looking for the x-axis symmetry. So we are going to let y be negative y equals negative absolute value of x minus 2. And really, all of those signs would flip, so that's definitely not what we started with. So let's look at the y-axis. And so with the y-axis, we are going to let x be negative x. And I think this one's going to work because I'm going to have the absolute value of negative x. And that's going to give me really the absolute value of just x, isn't it? Those are two of them are the same. So that is going to generate the same exact equation that I started with. So we are symmetric about the y-axis. Okay, so now we're going to talk about even and odd functions. And that's going to go along with symmetric about a certain axis. So a function is even. So we're going to say that it is even if it is symmetric with respect to the y-axis. And the algebraic check for that, remember we were subbing in a negative x and we were getting back our original function. So a function is odd if it is symmetric with respect to the origin. Odd is in respect to the origin, and that's because if we had our negative x, that gave me the same thing as negative f of x. So that's going to be the fast way to tell whether or not we have even or odd functions. So looking at the first one, we need to determine algebraically if the function is even, odd, or neither. If even or odd, then we tell, well, what kind of symmetry does it have? So for the first one, all right, so to figure out which one, we need to pick a test to start with. And notice that both of these we would sub in f at negative x. So I would have negative x raised to the third power minus a negative x. And so we do need to simplify that down. So that's going to be negative x cubed plus x. Now we need to compare that to the original and see what happened. Well, this looks like all of the signs have changed. If you notice, these signs are different. So that means it's going to be negative f of x. And if we investigate that over here, we would have a negative that we would need to distribute. And notice once we do, we end up with f of negative x. So this function is going to be odd. And if our function is odd, then we are symmetric about the origin. All right, let's look at number 8. Again, we always start out with f of negative x, and we're going to substitute that in. So we see that that's going to give me negative times positive x squared plus 6. So we see that f at negative x actually generated back my original function. So when that happens, we have an even function. And again, if our function is even, then we are symmetric about the y-axis. Okay, and then moving on to the next one, number 9. Again, same process here. So I'm going to look at what is f at negative x. So I'm going to have negative x all cubed minus negative x squared minus 2 times negative x. So we do need to simplify that. That's going to give me negative x cubed minus x squared plus 2x. So we need to compare that. Well, if we didn't get back the original function, so it's definitely not even. So let's see, what does negative f at x look like? So that would be negative, and then x cubed minus x squared minus 2x. And so if we distribute that negative, we have negative x cubed plus x squared plus 2x. That is still not our original function. So this one would be neither. Or, well, it's not either, neither. It is not even or odd. So I guess we would say none there. All right, so for number 10, again, let's substitute in f at negative x, square root, and we have negative x all squared minus 4. So that's just going to give me back x squared minus 4, which is what we started with. So then we are going to be even. And so we are symmetric about the y-axis. Okay, last two. Again, we need to look at f at negative x. So that's going to be a negative 8 over negative x, which is going to give me positive 8 over x. Well, that's not the original function, so we know it's not even. So now let's look at negative f at x. Well, that means I'm going to multiply the original by a negative. That's all that means. And notice if I do that, I have a positive 8 over x. So multiplying the original by a negative generated what I got when I substituted in negative x. So this function is odd. So therefore we are symmetric about the origin. Okay, last example. Again, we are going to sub in f at negative x. So we have the absolute value of negative x plus 1. Now, this is tempting to make that x negative, but that's not how our absolute values work. And so we have to take all of this and consider that value, then take the absolute value. So it's not going to work. Now, if I multiply the outside of the original, so here I'm going to multiply that by a negative. Again, that's not going to generate the original function for us. So this one we are going to be none. I'm not symmetric about either.